Hi, I am Revati, Assistant Professor, Department of EEE, SNS College of Technology. In this lecture series video of Fundamentals of Electrical and Electronics Engineering, today's topic is Basic Principle and Operations of DC Generator. So, in previous PPT, in previous classes, we have discussed about basic construction of an DC machines. So, here we are going to see about the principle and operation. So let's explore Faraday's law, Lenz's law, working principle, EMF equation and applications. So talking about DC generator, the law employed in this operation is Faraday's laws and Lenz's law. So identify the component. So you are provided with a two picture which is displayed in the presentation. So first one is your dynamo and second one is your motor. So the first one dynamo, which is symbolize that the DC generator is working in a mechanism of mechanical to electrical energy conversion. So that's dynamo act as a prime mover in this DC generator. So generator by motor, generator electrical energy, motor is mechanical energy. So we have discussed about energy conversion system, where in electrical motor electrical energy is converted into mechanical energy which act as a motor, whereas in generator mechanical energy is converted into electrical energy which act as a generator. So Faraday's law of electromagnetic induction is the major principle employed in the working principle of DC generator. So it employs two laws, first law and second law. First law is whenever the magnetic flux linked with a circuit changes, a EMF is always induced in it. Whenever a conductor cuts the magnetic flux lines, a EMF get induced. Second law is the magnitude of the induced EMF is equal to the rate of change of flux linkage. So that if you are considering a motor rotating part, so that the lines didn't cut the flux lines, so there is no EMF induced in it and the rotor doesn't rotate. So whenever the magnetic flux linked with a circuit cuts the magnetic lines, or the EMF get induced in the generator. So direction of induced EMF in a coil conductor is such that is opposes the cause of producing it. North and south pole, we know that opposite poles attract and the same poles repels. So in first picture, south and south pole gets to get in contact, so that it's a process of repulsion. And in the second picture, movement against attraction, so that the opposite poles get attracted. So Fleming's right hand rule states that the thumb represents the direction of motion and the first finger, forefinger represent field, magnetic field or electrical field. The second finger, that is middle finger, represent the direction of current. So the north and south pole is placed in between the conductor. The flux linkage lines are passed through south to north poles. The motion of the field is in the direction of the forefinger and the current in the direction of your middle finger. So basic requirement to be satisfied for generation of EMF is a uniform magnetic field is required, a system of conductor is required to carry the flux lines, relative motion between the magnetic field and the conductor is the major components which are required to satisfy the EMF which will get induced in a generator. So principle of operation, when a conductor moves in a magnetic field in such a way, conductor cuts across the magnetic lines of flux of lines and EMF produced in a generator, and it is defined by Faraday's law of electromagnetic induction. EMF causes current to flow if the conductor circuit is closed. So the DC generator converts mechanical energy into electrical energy. So that consider bicycle's dynamo as a mechanical energy which act as a prime mover which implies the mechanical energy. The after that the ignitions get started and the magnetic flux lines moves and the EMF get induced. So the mechanical energy is suddenly converted into an electrical energy within the terms of electromagnetic force. So operation of DC generator is represented in a pictorial representation, whereas first in A picture prime mover is connected, B picture the field rotation is get started and the flux lines will get cuts from 90 degree to 360 degree to complete one cycle Operation of DC generator, first of 0 to 180 degree path of current, and 180 degree to 360 degree is the second half. So EMF equation, we have to consider the P is equal to number of poles, pi is equal to flux, Z is equal to conductor, N is equal to speed of armature, A is equal to number of parallel path, which is classified into two types, wave winding and lap winding. So in wave winding, we have to consider A as 2. In lap winding, we have considered A as the number of poles, equal to number of poles. So we already know that lap winding is parallelly connected and wave winding is series connected. So the EMF equation is Eg, that's equal to PZ, poles into conductor into flux line into number of windings divided by 60 into A volts. So applications are, it is mainly used in charging batteries, DC locomotives, small power supplies, used for giving the excitation to the alternators, which is generators, used for general lighting, field excitation in DC motors, regenerative braking, is various types of distributive systems such as railway services. So principal operations are, whenever the current carrying conductor is placed in a magnetic field, the flux line get cuts and the EMF get induced. So these are the basic principle of a DC generator. In a situation, will the DC generator fails to produce voltage even though it is rotating. So if the speed of rotation of a DC generator is halved, what happened to the DC generator? So this is the basic curiosity challenges which you have to identify and comment in the comment section. So working principle of DC generator is based on Lenz's law, Ohm's law, Faraday's law and Kirchhoff's law. So we know that Faraday's law of electromagnetic induction. The EMF generated in the armature conductors of a DC generator is alternating current. So the reference links are given below. Thank you.